This is a video covering Assessment Standards 1.2 and 1.3 from the Relationships Unit, and this is both of the quadratic assessment standards. By the end of this video, you'll have seen each of the different question types and also have model solutions to each of those questions to ensure that you achieve full marks. Okay, so our first question is the diagram shows the parabola with the equation y equals kx squared, and we need to work out the value of k. Okay, so what we have here is a situation where we have three unknowns, y, k, and x, and we want to know two of those three unknowns so that we can solve this. So we have y equals kx squared. From the graph, okay, and they've got multiple points pinpointed, but from the graph you can see that you have the point here, 1, 5. Now this gives us a value for x and it gives us a value for y. So I'm going to substitute these in to my equation. I end up with 5 is equal to k times 1 squared. Now 1 squared is 1, so then that tells us that k is 5. And just to finally tidy up our solution, we can say that y is equal to 5x squared. Okay, but the k is equal to 5 is all we need as a solution. Okay, the next question. Sketch the graph y equals x minus 4, x plus 2. Mark clearly where the graph crosses both axes and state the coordinates of the turning point. Okay, so where the graph cuts the x-axis is the root, and that happens when y is 0. I'm writing x there, when y is 0. So y is equal to 0, so we have 0 is equal to x minus 4, x plus 2. So that means that x minus 4 equals 0, and x plus 2 equals 0. Then we get that x is 4, and x is negative 2. And these are the two roots of my quadratic. So the next thing I want to know is where it crosses the y-axis, and that happens when x is 0. So y is equal to 0 minus 4, 0 plus 2. Well, 0 minus 4 is negative 4, 0 plus 2 is 2, negative 4 times 2 is negative 8. So that's where we're crossing the y-axis. So that's your y-intercept. So there's your root. This is your y-intercept. Okay, so the next thing we want is our turning point. We get the x value by taking our two roots, so 4 plus negative 2, and then dividing them by 2. So 4 plus negative 2 gets you 2, divided by 2 gets you 1, and then the y part is then going to be 1 minus 4, 1 plus 2. So 1 minus 4, negative 3, 1 plus 2, 3, negative 3 times 3, negative 9. So our turning point is happening at 1, negative 9. Okay, so if I just come out of full screen for a moment, I can extend the page. Okay, move back into full screen. Oh, that should have extended the page. Let's try that again. Okay, so get the line tool. Okay, so I'm going to draw out my graph now. Okay, so what I have now is all of the information I need to mark in my important points. Okay, so I have roots at 4, and another root at negative 2. I have an intercept at negative 8, and then I have a turning point at 1, negative 9. So then all I'm going to do now is just join up my points. and I've sketched the quadratic. And that's worth 3 marks. One for your roots, one for your y-intercept and turning point, and the final one for a correct graph. Okay, moving on, we've got solving the equation x plus 1, x minus 7 equals 0. So what I want to do is then say that that means x plus 1 equals 0 and x minus 7 equals 0. So then x is equal to negative 1 and x is equal to 7. Now both of these have to be correct for the mark. Okay, so moving on now, we've got a quadratic, and the graph is in the form x plus al squared plus b, and a and b are integers. Now we know that a and b are the opposite of the turning point, the x part of the turning point plus the actual y part of the turning point. So what we have is that y is equal to x minus 1 all squared, because we're 1 along, plus 2 because we're 2 up. And that is all we have to do there. 1 mark for identifying A, 1 mark for identifying B. Okay, so a parabola has equation y equals x minus 3 all squared minus 4. Write down its axis of symmetry. Well, its axis of symmetry happens when this part is equal to 0. So it happens when x is equal to 3. And the coordinates of the turning point are going to be 3, negative 4, just taking the opposite of what's in here and what is written here. Okay, and then because this is a positive parabola, it means we're going to have a minimum turning point. Okay, and that's all we're doing there. 1 mark for correctly stating the equation of the line of symmetry, another mark for correctly stating the turning point, and a final mark for correctly stating whether or not it was a maximum or minimum. Okay, so moving on, solve the equation x squared minus 2x minus 4 using the quadratic formula. So I need my a, which is equal to 1, my b, which is equal to negative 2, and my c, which is equal to negative 4, and I need to substitute these into x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So substituting in all this information, I get the negative of negative 2, which is 2, plus or minus the square root of negative 2 squared minus 4 times 1 times negative 4. All divided by 2 times 1. Okay, so simplifying and separating, I get 2 plus root 20 over 2, or 2 minus root 20 over 2. I'm putting both of these into the calculator. I get 3.24 for one root, and then the other root is negative 1.24. Okay, and remember, quadratic formula is used when you can't factorize. Although you can use it if you can factorize and you don't know what to factorize, but this is where it's needed. It's not needed if you can factorize. And your final question, determine the nature of the roots of the equation 3x squared minus 5x plus 2 equals 0 using the discriminant. Okay, so this is a reasoning question because you have to state a conclusion. Anybody needing a 2.2, I believe this is, you absolutely need to nail this question. Okay, so we've got a value is equal to 3, b value is equal to negative 5, and c value is equal to 2. Your discriminant is b squared minus 4ac, so we're looking at negative 5 all squared minus 4 times 3 times 2. So negative 5 squared is 25, minus 4 times 3, which is 12, times 2, which is 24. So we're coming out with 1, which is greater than 0. So to conclude, we would say since b squared minus 4ac is greater than 0, we have two real distinct, that just means that they're different, two real distinct distinct roots. Okay, and that conclusion is the most important part of this, because that's where you're getting the reasoning element. Okay, so let's just fire back to the start and just double check that we've covered everything. Okay, so you've now seen each of the different question types, and you do in fact now have model solutions for each of these questions, so we should be getting full marks all round.